Hello, I'm Nathan, and in this video of Foundation Library, we'll be learning about async indexing in AEM. Indexing in AEM can broadly be divided into two types, sync and async. Today, we'll focus on async indexing. It is a scheduled process that runs after a specific interval of time, which can be configured using the async indexer service configuration. Now, this runs on the model of eventual consistency. That is, the index is configured to be updated using the async indexing will be eventually consistent with all the content changes that take place in the AEM repository. Now, before we get into the details as to what this async process actually does, we need to understand some core concepts that form an integral part of the async indexer service in AEM. First, the indexing lanes. These are nothing but a name given to parallel instances of the async index update process. An index definition in AEM can be registered on any of the configured lanes and gets updated when the process or the async job for that lane runs. To understand this better, consider these lanes as driving lanes with these stones placed at regular gaps. Now, consider these cars as the index definitions that are using these lanes to update their indexes with the latest content changes. The gap between these stones is the time duration after which the async index update process for that lane runs. This can be configured using the async indexer service config. Each configured lane will then run scheduled jobs for async index update as per its duration config. By default, we have async, full text async, and elastic async lanes configured in an out-of-the-box instance. But please do note, these are just names, and full text async lane can also have non-full text indexes as well, and vice versa. Second, checkpoints. So, checkpoint is a snapshot of an oak repository. Consider it as a way to preserve the state of an oak repository at a given point of time. And once it is created, it can then be used later on in future to get that exact same state. A checkpoint remains in the system until it's either explicitly removed or the default checkpoint lifetime, which is configured at the time of its creation, gets exceeded. Even the revision GC process cannot claim a checkpoint. The third part would be async index updates metadata. So this metadata is maintained on a hidden node on the oak repository, and it maintains the details of when any async index was last updated and the checkpoint up till which the indexes were last updated. These details are stored separately for each indexing lane. So now that we have covered these core concepts, we'll try and understand what this async index update job actually does. Please note that each run of the job is bound to a particular lane configured at any given point of time. There are n number of such jobs running in parallel given n number of lanes configured. The execution of these would depend upon the time interval between the jobs configured for each lane. So, first of all, the job gathers the details for the checkpoint a particular lane has been last indexed up to. This is done by reading the hidden async node that is used to store these details. Then the state from this checkpoint is read. If for any reason the checkpoint details are not available or the checkpoint no longer exists in the system, this is considered as an initial indexing, and the initial state in this case is taken as an empty state. In this case, the async index update job would traverse the whole repo and index the whole content for all the indexes registered on this lane. So once the initial or the before state is derived, it is evaluated if there are any visible diffs between this state and the current root state. In case of no such visible diffs, the run for the async index update is basically a no. However, in case there is a valid diff, a new checkpoint of the current state is then created. This is called an after state, and the checkpoint can be called as after checkpoint. We then process the diff between the before state and the after state. Now, all the index definitions bound to the current indexing lane are collected and their index editors are created, which are then passed the def callbacks. These index editors then update the respective indexes based on the calculated def. The index updates are either stored in the oak repo or on a remote storage based on the type of index, that is Lucene versus Elastic. Once the index updates are successful, the hidden async node is updated with the latest last index time, And we also set the after checkpoint as the reference checkpoint for the next run. Now all these changes are committed. In case there is no exception during the above steps and the changes get successfully committed, then the last reference before checkpoint is removed from the system. And in case the previous run was a failure, the lane is now marked as fixed. However, if there is any exception and somehow the changes don't get committed, then the current lane is marked as failing in case the previous run was a pass. And the reference checkpoint of the last index update timestamp in this case do not get updated. And the after checkpoint that was created during this particular run is removed from the system. In either of the cases, a cleanup of the older checkpoints is attempted in the end. So now that we've understood how the async index update process works, we'll see how we can monitor the same. We have statistics exposed in JMX, which can be used to monitor the state of the async indexing lanes. These JMXs show the information such as when the lane was last updated, what is its current status, is it passing or failing by any chance, if it is paused or not, how many updates it has processed, what is the last reference checkpoint, etc. etc. These are very useful when we need to diagnose any potential issues with async indexing. For instance, in case your search is not returning recent results and somehow you have a reason to believe that the indexes are not getting updated properly, then this would be your first place to start the diagnosis. So that was all from this edition of Foundation Library. Stay tuned for more such videos and learning content. Thank you.